Good morning, grade 10. Inshallah, today we will study with each other the general properties of waves or general wave properties. At first, when we study the general properties of waves, we have some points we must take care about them. Number one, the wave motion is what the meaning of wave motion. What the meaning of the wave motion? Wave motion is the propagation of the oscillatory movement or a disturbance from one region to another. Means if you throw, for example, if you throw a stone in a water pond, it will distribute by this way. This disturbance called wave. This disturbance called wave. If you open a speaker at your home, of course, this is called wave. So, what's the meaning of wave? Any disturbance in the medium which you can transfer, which you can propagate. The meaning of propagate means spread. The propagation means spread. This is the meaning of propagation. This is number one. Number two, a wave transfers energy from one place to another without transferring matter. Means what? If this wave happens, the particles will vibrate. The particles will vibrate, but the particles stay at the same place. Stay at the same place. If you have this pond of water and we put a dropper, the particles will move inside the water, but without what? Without transferring. The particles itself will not move. This is number one. All waves follow the laws of reflection and refraction, and this we will discuss it next. The waves, we have mechanical waves, two types of waves. We have mechanical waves and electromagnetic waves. The mechanical waves, like the water, air molecules, for propagation, means you need a medium to transfer. It can't move. Any wave, any mechanical wave cannot move without medium, without air, without water, without solids. It can't move. Electromagnetic waves, this can move without any medium, like they are a propagation of oscillation in electromagnetic fields. The propagation does not require any medium. It can move through a space, like the light of the sun. Light comes from the sun through the space without any medium, and we will explain this next inshallah. And it can move through the vacuum. This is number one. Number two, we classify the waves in this topic into two types: transverse waves and longitudinal waves. The transverse waves and longitudinal waves, and we will compare between them according to the study. Number one, what's the meaning of the transverse waves? Transverse waves mean the direction of the vibration particles. This is the particles motion. Particles motion is perpendicular on the direction of propagation. Perpendicular on the direction of propagation. If this is the direction of the particles, and this is the direction of propagation. The direction of propagation. This is number one. Number two, in the perpendicular, this here, the direction of the particles perpendicular on the wave propagation. Number two here, like what? Like the water waves. But take care, this is called the surface of the water, not inside the water. This, the water waves, but surface only. Surface only. Surface only, but not inside the water. Inside the water, it's a longitudinal wave. This is number one. Number 2, electromagnetic waves. Electromagnetic waves. All electromagnetic waves, such as light, such as infrared, such as visible spectrum, radio waves, gamma rays, X-rays, everything. Electromagnetic waves, all of them are transverse waves. But what are the properties or the characteristics of transverse waves? Number 1, in transverse waves, the particles oscillate perpendicularly. Perpendicular means it moves up and down, perpendicular on the direction of the travel. This is number 1. It consists of what? Peaks. This is called the peak. This one called peak. This is the peak, the highest point. And the down, this down called trough. Trough. In some books they call this crest, and they call this crest. So it's called the peak or crest and trough. Peak is the maximum displacement upward, and the trough is the maximum displacement but downward in the negative side. I mean, one of them is in the positive side and the other in the negative side. This is number 1. Number 2, the distance between the adjacent particles means what? When you calculate here the distance between them, of course, between the two peaks here, in this point, and this point, upward, this is called lambda, and we will explain it in the next point. This is number 1, transverse waves. Again, transverse waves, we said that the particles are moving perpendicular on the direction of the wave propagation. Number 2, we said example like water waves and electromagnetic waves. Number 3, we said consists of crests or peaks and troughs. This is number 1. Number 2, longitudinal waves. Longitudinal waves, here the direction of propagation, the direction of the motion of the particles in the same direction of propagation. What the meaning? This. Because both of them in the same direction. This is called compressions and rarefactions. Compressions mean the particles, they are nearer to each other, and rarefactions away from each other. The particles move away from each other. Here, the movement in the particle parallel to the direction of the propagation means they are moving in the same direction. Number 2, they are consist of compressions. This is called the compressions. The particles near from each other, and rarefactions, they are away from each other. Here, compression, what the meaning of compression? Compression means section in which the particles are closest together. Rarefactions means section in which the particles are farthest apart from each other. This is number 1. The distance between two centers of compressions and or two centers of rarefactions, we call this the wavelength. This is number 1 about comparison between the transverse waves and longitudinal waves. Take care when we describe the wave for both transverse wave and longitudinal waves, the particles oscillate about their undistributed position. Undistributed position means original position or a neutral position. They are moving through a neutral position. Take care about this origin because the vibration will oscillate from this point. Number 2, the neutral position lie along the axis of the direction. If we draw the direction here, this is called the original position. This about the comparison between the transverse waves and longitudinal waves, and what are the characteristics of the transverse waves and the longitudinal waves. And now we can write a very little question, compare between the transverse waves and the longitudinal waves. Thank you for watching, and goodbye.